Hello, everyone. My name is Hossein Khadivi Heris. I'm a Principal Applied AI Engineer in Microsoft. And today I'm going to talk about LLM app development using PromptFlow and Microsoft Azure Cosmos DB. I'm very excited to be part of this conference. Let's get started. In my presentation, first, I'm going to introduce you to PromptFlow for generative AI applications. Then I will talk about pf-Azure library and introduce the functionality of the library. And then I'll move on to show you a demo of how we can use pf-Azure DB library to build LLM applications using Azure Cosmos DB and also PromptFlow. During the demo, I will show you how you can establish connections to Azure Cosmos DB and Azure OpenAI in PromptFlow. I'll show how you can create a basic vector search retrieval flow using pf-Azure DB library. And finally, I'll show how you can orchestrate the LLM app components with PromptFlow. At the end, we'll discuss some remarks and have and show you some of our key takeaways. So what is PromptFlow? PromptFlow is an end-to-end development toolkit. It's a great tool for ideation, development, testing, and experimentation, and also and deployment of LLM applications. One of its key features is that it has a visual components where you can see all the components of your LLM applications as nodes inside a flow, where you can orchestrate each component with one another inside a flow as an input and output to one another. So having this visual flow development characteristic is a very useful tool for not only building the app, but also being able to do the debugging and orchestrating it. Also is a great tool for prompt engineering. It is well designed to be able to handle multiple prompts and being able to see what the effects and differences each prompt has on the end quality of your LLM application. It has very nice VS Code integration, which as a developer, we all really like about it. And finally, once you build an application with PromptFlow, going from building application to deployment is a very short process. So it saves you a lot of time in that sense. And it has pretty nice integration with Azure AI Studio. If you like to learn more, there is a link here on the slide that you can visit and follow along. Now, when we want to build retrieval augmented generation application, we always going to need to have a vector store. And as you all might know, Azure Cosmos DB offers vector search capabilities through PostgreSQL and MongoDB vCore. However, in order to be able to integrate these vector search capabilities with PromptFlow, you need to create Python nodes and start to write your own code and make sure that it is properly connected and you're doing the search in a correct way. And what we've done is basically we've tried to help you with that and create a PromptFlow tool that's packaged as a lightweight library where you can import inside PromptFlow and be able to do vector search operations easily. And if you would like to install this library in your Python environment, it's very simple. You can just simply do pip install pf-Azure DB, and the source code is available as open source on GitHub as well, and the link is shown on the slide. So let me quickly show you how you will set up your PromptFlow environment with VS Code. The first requirement is obviously you need to have a development environment, which in this case is Visual Studio Code. In your Visual Studio Code, you need to make sure that you have PromptFlow for VS Code extension installed and enabled. Also, you need a Python environment, and in your Python environment, the minimum you need to have PromptFlow, PromptFlow tools, and pf-azuredata. Once you install those libraries, you can easily go and create a flow, in this case flow.dag.yaml file. If you click on the visual editor, it takes you to your main flow, and you can see there are built-in tools like Python, LLM, and Prompt with PromptFlow. Now that we've installed pf-azuredb, you can also see Azure Cosmos DB MongoDB vCore vector search and Azure Cosmos DB Postgres vector search appeared as tools. There are other tools there which are installed separately, and it's outside the scope of this presentation. For our demo, we will look into a question and answering over financial transcripts. The goal is to assist the financial analyst with answering question on a financial transcript data. The sample data is available in a Azure Blob Storage. The link is on the slide. And our demo source code is also available in GitHub as open source code. The first step in building this app is to be able to provision vector databases. And the first, in this step, you need to create a PostgreSQL or a MongoDB vCore database in Cosmos DB. And once you have provisioned the database, either Postgres or MongoDB, you also need to make sure that you will obtain the connection strings from the Azure portal, which later will be used in the .env file of your application. You also need to provision LLM endpoint. Azure AI Studio makes that very simple. So you can create and deploy different type of LLMs in Azure AI Studio. In this particular case, you need at the minimum a text embedding ADA002 and one version of GPT available to you. Optionally, it's also recommended that you have a key vault where you can store all your keys. All the codes that I'm going to show, they also work with Key Vault as well. So in the next step, what we need to do in the PromptFlow is to establish the connections to the database and Azure OpenAI. And in this slide, I will walk you through that. First, for this project, you need to have the repository cloned. We have done that. On the left side, you can see the files of this repository, financial transcripts directory. There is a connection folder. There is this environment.yaml file, which contains all your Python dependencies. Make sure you update your Python environment with this environment.yaml file. As you can see, there is a sample template for the environment, m.sample. You need to complete this environment or keys from, instead of env, you can switch to Key Vault and obtain all the keys from your Key Vault. And once you've done, if you want to manually do that, you need to save it as .env file, as you can see on this screen. Now let's go and show how you can establish the connection. As an example, you can choose one of these connections. In this case, we will connect to an Azure OpenAI. You just need to run the Python script. It will take a little bit of time to connect the Azure OpenAI service to PromptFlow. But once that is established, we have access to Azure OpenAI inside our PromptFlow applications. So on the left side, you see the PromptFlow icon. And under the connections, you should be able to see all the established connections. In this case, we established a connection to AOAI, and you can see that on the screen. Other connections like CosmosDB connections or Postgres connections are also shown here. We've run the code previously, so they are readily available. The next step is to do pre-processing. In order to build applications, all the data needs to be chunked, embedded, and stored in a vector database. In the clone repository, there is a pre-processing folder. In the pre-processing folder, there is a data preprocessor Jupyter notebook. If you click on that Jupyter notebook and run that Jupyter notebook, it will download the data from Azure Blob Storage, and it will store it in the data folder. Now, if you click on the data folder, you're able to see the PDF files. The next step is to perform chunking, embedding, and storing the data. For MongoDB vCore and Postgres, we have prepared Jupyter notebooks that help you achieve this goal easily. So for example, if you run the pre-processing notebook for Postgres, it will load the data, it will extract some key metadata from the file names, such as the symbol, fiscal year, and the quarter. And there are functions that will take care of embedding, chunking, and storing data into the database. As you can see, there is a Postgres DB service class that has all the required functions to achieve that. By running this notebook, you will be able to store the chunk and embeddings into a table. You need to take note of the table name. In this case, was MSFD transcript. At this stage of the demo, I'd like to show you a retrieval of the data from a vector database using pf-azuredata library. Let's create a demo folder and simply create a new flow.dag.yaml file that will allow PromptFlow to recognize this file as a PromptFlow file. Now we go to the visual editor, add our input. In this case, we would like to ask a question. This is going to be our query. Its type is a string. We can fill the default value later. As an output, we would like to retrieve the docs. Now, let's add the nodes for embedding and also add the node for Postgres vector search retrieval. Once you added these nodes, it takes a little bit of time to generate its tool metadata. You can also easily rename the name of the node if you wish so. Now our output, we define that the output of our flow, which are the retrieve docs, are coming from the Azure Cosmos DB Postgres vector search node. Now let's add a simple question. What was Azure ML revenue? And perform a vector search operation. Now we define the connection names, the deployment name, and we also define the input to this node, the embedding node. And the embedding node's input is coming from our input query. Now for Azure Cosmos DB vector search, we define the name of the connection that we've already established, the table name, which in this case is MSFT transcript, the search type is vector, number of results we want to retrieve, 3, and the question that we would like to ask. And this option is useful for a hybrid search. For vector search method, there are different ways to do so, such as inner product or cosine similarity, and you define that. Now let's run the flow. It will take the input, create an embedding, and then using pf-azuredata library, it will retrieve the data from the database. If you go to the Cosmos DB Postgres vector search node and go to the output tab, you will be able to see the 3 retrieved documents along with the metadata. The final step of building our LLM application in PromptFlow is the orchestration. When building LLM applications, especially in a RAG pattern, you need different components. You need to have retrievals from vector databases. You need to create LLM calls in order to make the completions. You also might require to do some custom Python coding for formatting the input and output. So in this case, we have built the complete flow, and we've embedded the retrieval that I showed earlier from the pf-azuredata library into the complete orchestration. So in this folder, there are RAG Cosmos DB Mongo and RAG Cosmos Postgres folders, and each of them contains complete application for the use case that I described. If we go to the RAG Cosmos DB Postgres and create and click on flow.dag.yaml file, you will see all the components of this application in the YAML file, but also there are other files in this folder that are used for either pre-processing, or there are Jinja files that are the prompts for LLM calls. There is also a parameter config, which we can set outside our flow, and we can define some hyperparameters such as search type, table name, the top K, and vector search method without hard coding them in the actual flow. That helps us eventually with experimentation and optimization of our application. Here in this case, we are asking a question with respect to a specific year and quarter, and we are running it in a standard mode. And the input data is flowing through different nodes, and eventually it will be completed as an output. So as you can see, we can check the output, and from the setting that we had, the database was not able to retrieve the right information because we had only top one and retrieving only one document from our vector database didn't allow us to retrieve the right information. Now what we can do is to go our param-config.yaml file and perhaps change the top K to 3. We can even do more sophisticated operations, such as instead of vector search, we do filtering and vector search, which reduces the search space for our vector search retrieval. And now if we go back to Flow and try with the new setting and run the Flow in standard mode again, and check the output, now we can see that the right information was retrieved and LLM is able to provide us with the correct answer. In order to optimize our LLM application, often we need to generate benchmark questions and answers and evaluate them systematically. In this repo, there's also evaluation flows that are pre-built. For example, we have built all the evaluation scores from Azure AI Studio into a flow that it can be coupled with our main application. And also we have an experimentation folder, and in that folder you can find batch evaluation notebooks. And in this case, instead of running a single question and answer and getting the answer from a flow, we define tens or hundreds of benchmark questions and answer. We can also define the configuration and run this notebook to analyze the results in a batch mode. And once we check the evaluation outcome, we can pick the correct hyperparameters for our application. If you'd like to learn more about evaluation and experimentation, you can refer to the README in this repository, and it will walk you through the steps and learn more about this from the README. Finally, let's look at some key takeaways. CosmosDB's built-in vector search capabilities allow us to build scalable LLM applications without moving data outside operation database, which is a great advantage for a vector search database. I also showed how PromptFlow provides essential tools for development, experimentation, and evaluation of LLM applications. Finally, PromptFlow Azure DB tool was introduced, and hopefully you will find it useful for your application and help you speed up building generative AI applications in PromptFlow. Finally, I'd like to acknowledge my collaborators, Journey McDowell and Sandeep Kulkarni, for helping me with this project. Thank you for your attention.